I've always been somebody that's enjoyed goals and achieving those goals, and I've been somebody that's been interested in progressing throughout my entire life. One way to do that physically is I like to do CrossFit. My name is David Brough, and I'm a graduate student here at BYU. I've been studying physics for a year. The idea behind CrossFit is that you're trying to be physically fit in basically every aspect of your life. And so with that, there's a lot of running, a lot of weightlifting, and I think through having something that's that hard as CrossFit, it gives you an opportunity to refine your character if you push hard through those difficult times. So it's a way for me to achieve my goals physically, and I think it makes me stronger mentally as a person. CrossFit gives me a way to try to improve myself, make myself faster and stronger, and with my research I'm trying to make things smaller and more efficient. When I chose to come to BYU, I came because I really was interested in some of the research that was going on here. I work in the Nanophysics group here at BYU, and in the Nanophysics group we do all kinds of applications with carbon nanotubes. If you were to take 4,000 of these nanotubes and line them up side by side, then it would be as thick as a human hair. So they're pretty small. It's kind of hard to imagine. My group does a bunch of different applications with carbon nanotubes. Some people are doing self-assembling electronics, so basically you could throw chemicals in a test tube and it would assemble into really small electronics. Other people are making really efficient water filters that could be produced cheaply. They could be sent to third world countries to help them get the water that they need. Others are making really strong carbon composite materials. There are others that are looking at using carbon nanotubes in solar energy projects as well. I use carbon nanotubes to improve batteries. So inside a battery, you have two electrodes. There's the lithium electrode, and then there's also a graphite electrode. The reason why graphite's used currently in commercial batteries is because of its really good cyclability. You're able to charge it thousands of times without losing a lot of your capacity or a lot of the charge that you're able to get each time you charge it. If we were able to use silicon as an anode, then we'd be able to potentially get 10 times the amount of power in the same size of a device. And so what I'm looking to do is we look at coating these carbon nanotubes with silicon and then use them as an electrode inside of the nanostructured batteries. So basically we're working on making batteries smaller and 10 times better. The facilities here at BYU are great. There's a clean room here at BYU that I use for photolithography. There's chemical rooms that are available. There's an SEM, scanning electron microscope, as well as a TEM that I also use for my research as well. So these equipment help me to fabricate my electrode and then also to test them and to be able to better understand what's going inside the battery and understand the physics that's going on there. In the research group that I work with, there are two professors that I'm able to work with. One is Dr. Davis, and he's essentially the carbon nanotube guru. The other advisor I work with is Dr. Van Fleet, and he is a microscopist. They're available when we need them. They always provide good insights when I run into issues with my research and are able to point me in directions that I need in order to overcome the issues that we're working on. And they ask a lot of us and want us to work hard, but they also create a good environment for us to grow and learn. Even though I've been at BYU for only a year, I felt like I've been pushed tremendously. I feel like I've made a lot of strides in my research and understanding the world around me. BYU is a great school and I'd recommend it to anybody.